Good morning, friends. Today we are going to discuss TGPSC Pollution Control Board Paper 2 Chemistry. Next third lesson Chemical Bonding. కెమికల్ బాండింగ్ లో మనకి చాలా సినాప్సిస్ ఉంటాయి. ఒకసారి మీరు చూడండి. టైప్స్ ఆఫ్ బాండింగ్, ఓవర్లాపింగ్ ఆఫ్ అటామిక్ ఆర్బిటల్, సిగ్మా అండ్ పై బాండ్స్, హైడ్రోజన్ బాండింగ్, మెటాలిక్ బాండింగ్, అండ్ వెస్పర్స్ థియరీ, right? Hybridization and MOT. So these all very important in chemical bonding. Based on this, some important questions and quick brief we can see. Okay, so don't miss this channel and you have to subscribe for more details. And I will complete total syllabus up to July. So do follow my channel. Okay, we'll start the class. See, first one, all of you concentrate. First one is what I selected. Yes, all of you see this. Here, TGPSC, right? TGPSC paper 2 chemistry chemical bonding topic. Our topic is chemical bonding. Okay, we are discussing now just 25 VSCQs. 25 VSCQs with best solutions. 25 VSCQs with the best solution. These are important from this topic. Okay, we'll see now which bond is formed by transfer of electrons. Very important. Okay, so this is types of bond. Okay, so we know this here. Ionic bond is formed by the transfer of electron. We'll go for one example. See here, example also there here. I will explain clearly. See, ionic bond means here sodium I am taking and chloride I am taking. Sodium has here 11 electrons, whereas chlorine is 17 electrons. Okay, after losing of one electron, this it become here 10 electrons. Okay, 10 electrons. So sodium is 10 electrons. 10 electrons. Similarly, chloride. Here chlorine adding one electron, then become one Cl minus. Cl minus instance here it is 18 electron. 18 electron. See now what happened? From sodium to chloride, electron transfer taking place. Therefore, by transferring of electron, ionic bond is formed. So therefore, sodium chloride is formed by the transferring of electrons. Clear, students? This is the simple concept about here. Ionic bond is formed by the transferring of electron. So your answer is ionic bond. Next question you see, which bond is formed by sharing of electron? Again, same question here, but sharing asking. They are transferring, they are sharing. Covalent bond is formed by the sharing of electron. See, I given here best example to understand this. Covalent bond. What is covalent bond? Covalent bond involves mutual sharing of electrons. Mutual sharing of electron between two atoms. So that is homo or sometimes hetero. Example H2 molecule. How it is formed here? Hydrogen and one more hydrogen. These two hydrogens are mutually sharing their electrons like this, equal sharing, and form here H2 molecule. Clear, sir? So like this will form here H2 molecule. We can write here H mod H. Also we can write here H2 molecule. Clear? So like this here, mutual sharing of electron, covalent bond is formed. Clear, sir? That is your answer is covalent bond. Next question you see, overlapping of atomic orbitals leads to formation of overlapping overlapping of atomic orbitals leads to formation of basket. So here, any atomic orbitals overlap in form generally is bond. So that is which bond means chemical bonding. What is this? Chemical bonding. That is not nucleus, that is not hybridization orbitals, that is not ions. Any overlapping is taking place, that is called what? Chemical bonding is called. So that is here. So overlapping is more effective. Overlapping is more effective. Overlapping means we have here SS overlapping, PSP overlapping, PP overlapping, right? And PD overlapping, like this here, DD overlapping, like so many overlappings are there. So this overlapping is more effective, more effective. So between these two nuclei are atom and form a bond. So that is your chemical bonding. Clear? Next one, see, add-on-add overlapping. Add-on-add overlaps forms. So here add-on overlapping will get here sigma bond. That is also called end-on-end overlapping. End-on-end overlapping. What is this? For example, you can take here, this is sigma bond of p orbital overlap with one more sigma. This is called here end-on-end overlapping. This will leads to form here sigma bond. Which bond it is? Sigma. Sigma bond is formed. Clear, right? So that is your answer is sigma bond. Sigma bond. Next one. See, fifth question. Sidewise overlap leads to form. Sidewise means here you are taking same example like this. Here, this is one p orbital. This is one more p orbital, and these two are overlap each other like this. Sidewise. This is called here sidewise overlapping or lateral overlapping. Sidewise or lateral overlapping. So this type of overlapping leads to form your what? This type of overlapping leads to form your what? Pi bond. Which bond is formed? Pi bond is formed. Clear, students? Any doubt here? Yeah, that is it. So here first one is sigma bond. Second one is pi bond. Pi bond is formed. Okay. So that is your pi bond. Next one. See, lateral overlapping also we can see. Right? Next one, sixth one. Which bond is stronger? Very important question this is. Which bond is stronger? You tell me which bond is strong. End on end overlapping, making secant type of disease. And sidewise or lateral overlapping, right? This is not a strong bond. This is weak bond. Clear? So this is weak bond. So pi bond is weak bond. That is nothing but pi bond is weak bond. And sigma bond is strong bond because end on end overlapping. So end on end overlapping will give you strong bond. Therefore, you can say which bond is strong bond? Sigma bond is strong bond. Clear? Next one, we'll see. We'll see here. Hydrogen bond is strongest in is asking. Hydrogen bond also is strongest in. So which molecule hydrogen bond is strong means actually what is hydrogen bond? You can take here hydrogen is formed bond with most electronegative elements like fluorine, oxygen, and nitrogen. That's it. This electronegativity of fluorine is 4, oxygen is 3.5, and nitrogen is 3. So these three are participating in hydrogen bonding. So these compounds we can see for one. First one is HF is formed hydrogen bonding and H2O is formed water molecule hydrogen bonding and NH3 also form hydrogen bonding. See the option which is there here. See that here option is HF is there and NH3 is there and HCl is there and PS3 is there. But in this, these two are will form a hydrogen bonding because nitrogen is there, fluorine is there. But which is strong means which is more electronegative. So which is more electronegative? Fluorine is more electronegative. Therefore, this will form more hydrogen strongest bond. Clear? That is. Next one, you see solution also given here. Fluorine has high electronegative, just now I said, and small size compared to all, and leading strong hydrogen bond. These two are reasons for that. Clear, sir? Next one, metallic bond is due to very important. Metallic bond is due to it is formed here. Actually, metallic bond is based on the VBT, valence bond theory. It is also called C of electron theory. C of electron theory. What is C of electron theory? You can take here, for example, this is a water pond or sea water, and here we have in a boat. You can select in a boat. So this boat is like a metal positive charge. This sea water is nothing but electrons. So between these two, there is a means relation attraction, that is metal atom metal atom, so many metal atoms surrounded by the sea of electrons. This is called a metallic bond. So many metals are come close and release their electrons. These losing electrons are surrounded by the same metal. For example, copper wire. Copper wire is used as a electrical conductor because on the surface of the copper wire, so many electrons are present. That is called here free electrons. Therefore, it is a good conductor. It is a good conductor. It is a good conductor. Clear? So these electrons, whenever we are applying voltage, these electrons are helping move forward one terminal to another terminal. Therefore, this type of bond is present in a metals. Therefore, here see that is attraction between metal ions and its electron cloud. That is called here sea of electron theory. So sharing of electron is not possible. Transfer of electron not possible. Hydrogen bond not there. But here attraction between metal ions and electron cloud. This is called metallic bond. Clear, student? That is your answer. Next one. You know, bond order. Bond order of O2. Very, very important. I will explain clearly what is bond order, how to find. Be careful. So bond order we can calculate by so many methods. Okay. So now I will go for bond order of this by logical manner. Logical Logically I will explain. Be careful. For example, I want bond order of O2. Bond order is equal to bonding molecular orbital electrons minus anti-bonding molecular orbital anti-bonding molecular 1 minute. Is anti-bonding molecular orbital electrons by 2. This is the formula for bond order. Now we need to use this one by taking O2. How to find AC? O2 means oxygen. Oxygen, oxygen here, atomic number 8. How many oxygens are there? 2 oxygen. Total number of electrons are 16. This is simple logic. If you know the 16, you will get the easy bond order. How? You can write here. Bond order is equal to 16. You can write as 16. You can write as 10 minus 6 by 2. That's it. We will get the answer. So what is the answer? So that is here 16 10 minus 6. So that is nothing but 4 by 2 is equal to 2. That is nothing but between two oxygen atoms, two bonds are present. This is called a bond order. Therefore, it is mostly we know double bond. Oxygen contain which bond? Double bond. So we know this oxygen contain double bond. Therefore, bond order is 2. Bond order means number of bonds between two atoms. Number of bonds between two atoms are 2. Therefore, bond order is 2. Your answer is 2. Okay. If you have got here one more, for example, sometimes they are asking O2 minus. Then sir, nothing will happen. 18, actually it is total 16. Minus means addition of electrons in the chemistry. So it is 17. 17 means how can you write 7, 10 minus 7 by 2. So that is nothing but what? 3 by 2. 3 by 2. 3 by 2 means 1.5 is the bond. For example, they are asking, sir, they are asking O plus O2 plus 2, somewhat whatever it may be. Then what happened? No problem. Here also you can take here plus means here removal of electron. Actually 16. 16 minus 2. You get here 14. 14 means how can you write 10 minus 4 by 2. So we'll get here 6 by 2. 6 by 2 is equal to 3. So bond order is 3. Like this we can find the bond order of any molecule. Okay. We'll discuss future if same question will ask. Okay. That is the concept. Any doubt in this? Yes. Next we'll go for here. Higher bond order means very very important. Higher bond order means actually bond order means number of bonds. Bond order means number of bonds. Number of bonds between two atoms. Between two atoms or molecules. Two atoms are molecule in the molecule. So for example, you can take here What is the uh, highest bond means? For example, we'll go for one example. I will give you one best example to understand this concept. All of you concentrate. Very important. Very important. See here. What is this? I am taking here carbon compounds. C single bond C. C double bond C. C triple bond C. Then what happened? C single bond C. Bond order. Bond order is how many bonds are there? One. So bond order is one. How many bonds are there? Bond order two. How many bonds are three? So here we'll go for here. Here we need to take here I bond order means high on bond means we need to go for here bond energy we can discuss. Bond energy. Actually bond energy of this one it required to break the bond here almost here 340 kilojoules for mole energy required, isn't it? Here for this one 610 kilojoules per mole required. Here 827 kilojoules per mole energy. See what happened when number of bonds increases, bond energy increases. So which is strongest bond? Tell me which is strongest bond means this is strongest bond. See now what is the question? Higher bond order means what? Longer bond length? No. Here bond length also we can write here. Bond length. This is 1.54 angstrom units. This is 1.34 angstrom units. This is 1.21 angstrom units. See bond length is decreases, bond energy increases, and bond order is increases. So we can say bond order is directly proportional to bond energy and bond order is is inversely proportional to bond length. See this? See more the bond order, lesser the bond length. Clear? So your answer is you can check it out. Here stronger bond. Stronger bond is higher the bond length. Higher the bond length means, for example, this is example. More the bond order, more the energy required. That is, more strong is the bond. Clear? That is. So greater the bond order means and stronger the attraction and shorter the bond length. Shorter the bond length. Clear shades? Any doubt in this? Right. Very good. Now we'll go for here. Shape of molecule. Which molecule it is? See this CH4 molecule, methane molecule. So what is the shape of this molecule? We can go for here. Methane molecule. Methane 1, 2, 3, 4 hydrogens. We can keep it. 4 hydrogens. Right? Like this, we can keep 4 hydrogens. Now you can draw uh, assumed shape. You can keep the dots like this. Yeah. We can observe what happened here. You can observe here. This is one wall. This is second wall. This is third wall. This is fourth wall. You can pick it up here on carbon, and I can means you can lift up. So how many walls we can see? Four. Four means what? In chemistry, four means tetra. Tetra. Hydral means one. Tetrahydral. Tetrahedral. So where is the option tetrahedral? Yes, this is tetrahedral shape. So here when tetrahedral is there, that hybridization is sp3, bond angle is 109 degrees 28 minutes. That is the common concept. We'll discuss if required in future, right? That is also. So shape of BeCl2. BeCl2. So BeCl2 means beryllium chloride like this. Beryllium valency 2. So it is attached to two chlorides. Therefore, see this is a linear shape, 180 degrees. Bond angle shape is linear molecule. So where is the option? You can see. And hybridization is sp. Sp hybridization has linear shape and 180 bond. So your answer is linear is correct. Clear? According to Vesper theory, no lone pairs. No lone pairs. If lone pairs are present, shape will be changed. So, okay. See on this no lone pairs. Therefore, how to find lone pairs? Lone pair electrons is equal to number of bonds. How many bonds are there? Number of sigma bonds. Number of sigma bonds. Number of sigma bonds. Right? Minus, isn't it? So you can take like this. Otherwise, we'll go for one more small shortcut. One more shortcut here. You see. So group number you can take group number, group number minus number of bonds, right? You can see group number is beryllium atomic number 4. You can subtract 2 from this, you get the group number. It is second group. So second group means 2. Number of bonds are 2 sigma bonds. Only sigma, 2 sigma. 2 minus 2, 0 lone pairs. So lone pairs are 0. Like this, we can find the lone pairs. Come here, shape of NH3 is asking. So say as it is NH3, like this. We'll go for this. Here one lone pair is there on this central atom. So this is pyramidal shape. What is this? Pyramidal shape. So we can say trigonal pyramidal. So according to whisper theory, we can go for this. How to find the shape means, see this, actually nitrogen atomic number 7 minus 2 will get your fifth group. Fifth group means lone pairs you can find. Group number 5, number of bonds are 1, 2, 3 bonds. So you can see 3. So that is 2. 2 are electrons, that is lone pair. So you can go for hybridization. Hybridization is equal to number of sigma bonds plus lone pairs. Number of sigma bonds are 3, lone pair is 1, that is 4. 4 means we can write 1 plus 3. 1 means s orbital, 3 means your p orbital. So 1, 2, 3. So this is s means 1, p means 3. So hybridization is sp3. So when sp3, actually it is lone pair of electron. Due to lone pair of electron, the shape is pyramidal. Pyramidal shape. Clear? And bond angle is 109, 107 degrees, 48 minutes. Hybridization sp3. So that is about molecule. So this 107. It has one lone pair. Clear? Next one, shape of water molecule. Similarly, according to Whisper theory, it is bent molecule. So you can take your water molecule like this. This is water molecule, right? It has two lone pair of electron. According to Whisper theory, more repulsion. That is lone pair repulsion. In the case of here, lone pair bond pair repulsion, isn't it? So according to Whisper theory, lone pair repulsion more than that of lone pair bond pair, then bond pair. So this is more. Therefore, the bond angle is decreases from 107 to 104 degrees, 28 minutes. So it is a V shape, or we can say bent shape. V shape it is bent, or we can say reverse V shape. Also we can say angular angular shape of water molecule. Right? Here also hybridization is sp3. Right? Bond angle is 104 degrees 28 minutes. Right? And shape is V shape. V shape. Don't forget this. Clear? That is about our class. Next one, Vesper theory based on very important is. So it is based on just now what we are discussing, lone pairs, lone pairs. Therefore, it is lone pair. Due to lone pair, due to lone pair, due to lone pair, whatever you know, due to lone pair, it is affected by bond angles and shape of the molecule. Shape of the molecule. These two are affected by the lone pairs. Just now we discussed. You see, in BeCl2, no lone pairs. Therefore, the shape is linear, bond angle is 180, hybridization sp2. But in the case of ammonia, it has one lone pair. Due to one lone pair, repulsion is taking place. Due to repulsion, bond angle is changed from, actually its original bond angle is 109 degrees, 28 minutes actually. Okay, is similar to methane, in the methane. But due to lone pair, in methane no lone pair in methane, isn't it? But in ammonia there is a one lone pair. Therefore, this bond angle changes from 109 to 107 degrees. You can see 107. That is due to lone pair. And actually, methane tetrahedral shape. But this shape is not tetrahedral, pyramidal because of lone pair. Therefore, due to lone pair, its bond angle and shape both are distorted. Similarly, you can take a Now water molecule, two lone pairs are there. Due to two lone pairs, the shape also bent shape. It is distorted from tetrahedral to and bent shape, isn't it? Or V shape. And so bond angle actually it is also 109 degrees 28 minutes, but it is distorted due to two lone pair repulsion. It become as a 104 degrees. So that is so here Vesper theory based on means lone pairs. Due to lone pairs, what happening? Yes, what happening means bond angle and shape of the molecule will be distorted. That is a clear information. See this electron pair repulsions and see electron pair repulse the each and arrange the minimize repulsions. Okay, based on the lone pair, bond pair, repulsion is taking place. Due to repulsion, these two are effective. Clear? That's it. Next one, which E has maximum bond angle? Very important, isn't it? So we can go for here. We can go for here. NH3. Just now we discussed NH3, right? Here, NH3 107 degrees 48 minutes bond angle, right? According to Whisper theory. And H2O, just now we discussed 104 degrees 28 minutes. 28 minutes. Whereas methane, no lone pair, see 109 degrees 28 minutes. 28 minutes. Right? In the case of CO2, CO2 is a linear molecule. Linear molecule. Due to linearity, see hybridization is sp because only two sigma bonds, two pi bonds are there. So sp means 180 degrees bond angle. Therefore, it has highest bond angle compared to R. So this is 180 bond angle. Clear? Sir? So our answer is CO2. Right. We'll go for here. Yeah, this is linear shape. Okay. Linear 180 means linear. That's it. Linear shape. Next, we'll go for hybridization of uh, C2 H2. This is becomes ethylene. C2 H2 means IUPAC name is ethene. Ethene. This is IUPAC name and common name is ethylene. This is common name. So both we consider, right? So what is the hybridization? Simple. In carbon chemistry, so we'll discuss 17, 18, right? Together. Yeah, all of you concentrate. Together we'll discuss. Okay. What is this? Actually, in carbon compound, carbon will give you only uh, three types of ionizations. One is sp, second one is sp2, third one is sp3. That's it. Where sp, sp2 will discuss. Here, sp is in alkynes, alkyne. Here, sp2 means alkene, alkene. sp3 is alkanes, alkenes, right? Alkenes. Okay. See, what is the difference between this? Alkyne means we have a CC triple bond. Alkene means double bond. Alkene means single bond. So all single bond compounds, for example, one compound is like this, it contains triple bond. One compound is like this, it contains double bond. One compound is like this, no single bond, no double bond or triple bond. Like this. You go for this. Whatever you see, all of you see. So this carbon, single bonded carbon. Therefore, it is sp3 hybridization. This carbon, triple bond carbon, sp. This carbon, triple bond attached carbon, sp. This carbon, single bond attached carbon, sp3. That's it. Clear? Now you can see this carbon, this carbon, this carbon, this carbon. Just now we discussed. This is sp3. This is double bonded sp2. Here sp2. Here sp3. Simple. 1, 2, 3, 4. You tell me. You tell me now. What are the? All are single bond. So all four are sp3 carbons. Like this, easily we can find. Now is asking ethylene. Ethylene means CH2 double bond CH2. Okay. Now tell me. Easily we can give the answer. Double bonded carbon. Therefore it is sp2. Double bond carbon. Therefore sp2. Now tell me what is the answer. Your answer is sp2 is correct. Sp2 is correct. Clear? Similarly, we'll go for next question. As it is, you can give the answer. What is the next question? C2H2. That is nothing but CH triple bond CH. See, this is triple bond carbon, therefore sp. This is also triple bond carbon sp. Your answer is sp. This much easy hybridization of this. Okay. So here it is sp2 means trigonal planar. Trigonal planar. Trigonal planar means 120 degrees bond angle. Don't forget. Here sp means it is linear. Linear. Okay. And bond angle is 180 degrees. This is common concept for all. Okay. That is our information. Next we will see shape of shape associated with the sp2 hybridization. Just now I said sp2 means sp2 means without lone pairs. Without lone pairs. Without lone pairs. Trigonal planar and 120 degrees bond angle. Don't forget this. So what is the answer? See, this is trigonal planar. Trigonal planar. Hybridization sp2 120 bond angle. That's it. Clear. Now we'll go for here. Shape associated with the SP evolution just now. SP means always without lone pairs. The linear shape, right? And linear means always 180 degrees bond angle. So our answer is linear. That's it. Next we'll go for which molecule is paramagnetic. Very important. So here mostly nitrogen diamagnetic. Okay, H2 diamagnetic, CO diamagnetic. Only O2 is paramagnetic. Here, so O2 in a MOED molecular orbital energy diagram. In a anti-bonding. Here we can go for here 2 pi, and 1 minute. Yeah, sigma 2px, pi 2py, pi 2pz are transcended antibond. But here in uh, pi 2py 1 electron, pi 2pz 1 electron. Two unpaired electrons are present in a anti-bonding in MOID diagram. Therefore, oxygen is paramagnetic. Okay, because of two unpaired electrons are present. Okay, I will explain full diagram when it required. Clear? That is. So remaining are not having unpaired electrons. They are pair electrons. Clear? Next one, molecular orbital theory. How to explain molecular orbital theory? So it explain what? First we'll go for molecular orbital theory. First thing. See, this is called here molecular orbital energy diagram. Here we have uh, atomic orbitals, molecular orbitals, and we can say here uh, bonding molecular orbitals, anti-bonding molecular orbitals, anti-bonding molecular orbitals. Like this here, there are three types of orbitals. These three orbitals we can frame in a MOID diagram. See, I am taking like this MOID diagram. All of you concentrate. What is MOID diagram? So this is called here atomic orbital. Atomic orbital. This down one is bonding molecular orbital. Here upper one is anti-bonding molecular art. This is MOIT diagram. This is energy. Energy order we are taking. Energy order we are taking. Energy order we are taking. Clear? Now, based on this, we can see by using molecular orbital diagram, what we can explain. First point is very important. First point is bond order. Second point is magnetic property. Magnetic property. That's it. These two are important. And third one also there, electronic configuration. Electronic configuration of molecule. These 3 points are important. Okay. So we'll discuss one example and explain clearly. So first one you can see 22 question answer. So molecular orbital theory explains. So that is here bonding and magnetic properties. Clear? So MOT explain bond order, stability, magnetic property, and electronic configuration also. Clear? So this is here energy order. Energy order also important. Energy order of this one means see which is least one BMO. So BMO is least energy, then AO followed by ABMO. ABMO. This is the energy order of Earth. Now bond order of N2 molecule. Just now we discussed bond order of N2 molecule. Nitrogen atomic number 7, 7 plus 7, 14. So you can write here bond order is equal to 14 means how to write 10 minus 4 by 2. So answer is 6 by 2 is equal to 3. Your answer is 3. This is the way. So don't go lengthy. Shortcut is yes. This is the answer. Right? Clear? Now we'll go for which homo diatomic molecule has bond order is 0. See this here, zero group elements mostly. Zero group elements do not contain any bond order. Example we'll check it out. Helium. Helium is giving He2. This is not possible. That is He bond He is not possible. He bond is not possible because zero group elements do not participate in chemical bond. I will explain clearly how it is not possible. I am taking here one He here, right? Electronic configuration 1s2 atomic number 2. One more He atomic number 2 1s2. I am taking here this orbital energy. This is here. This is called linear combination of atomic orbital LCAO. LCAO. Linear means 1s2 to 1s2, 2s2 to 2s2, 2p2 to 2p2, 3s2 to 3s2. This is called linear combination. I am taking here 1s orbital here. See this diagram like this. I frame MOID diagram for you. This is 1s2 orbital of this helium. This is 1s2 orbital of another helium. Right? Now this is atomic orbital. This is also atomic orbital. This is we just now discussed bonding molecular orbital. This is anti-bonding molecular orbital. Clear students? Now what happens is now how many electrons here? Two electrons are here. How many electrons? Two electrons. The two electrons are here. Two electrons are here. That is atomic orbitals we fill. Now this total electrons 2 plus 2 how much? 4. This 4 we are filling according to On's rule, least energy we need to fill. Above principle also will give you least energy first, then pairing of electron taking. So 4 electron means first 1, second 2. After filling of this, we'll go for antibody 4. This is the filling of orbitals by taking given electrons. Clear? Sure. Now, how to find bond order? Bond order is equal to bonding molecular orbital electrons minus anti-bonding molecular orbital electrons by 2. Now tell me, how many electrons are bonding? 2 electrons. How many electrons in anti-bonding? 2 electrons. By 2. So what will get? 0 by 2. 0 by 2 means 0. Means no bond. No bond between helium to helium. This is your answer. So it is not possible. Therefore, therefore, He2 is not possible according to this theory. Clear, sir? So this is the answer is He2. Remaining are possible. Remaining are possible. See this. Bonding electrons are 2. Anti-bonding electrons are 2. This is 2, 2, 2, 2. Clear. So bond order is 0. See bond order is 0. So hence does not exist. Clear? Any doubt? Yeah. So last one, shortest bond length observed in, yeah, just now I explained. So where shortest bond length means triple bond. See, triple bond, according to this I am taking, triple bond means carbon I am selecting, double bond means carbon I am selecting, single bond also carbon I am selecting. Okay, this is 10th order. So is asking shortest bond length. So this is how many bond order is? 3. Bond order is 2. This is bond order. Bond order. Bond order is 1. Here bond length we are taking. Is asking length now? Bond length is asking. So I am taking bond length, all of you see this. Bond length. Okay. Bond length is here 1.21 angstrom units bond length. Here 1.34 angstrom units. 1.54 angstrom units. Now tell me, shortest bond, single bond, double bond, triple bond, hydrogen bond is not possible. So our answer is triple bond. So this is less value, more bond order. So bond order inversely proportional to bond length. This is your importance of పొల్యూషన్ కంట్రోల్ బోర్డ్. సో థ్యాంక్ యూ ఫ్రెండ్స్, తప్పకుండా నా ఛానల్ని మీరు సబ్స్క్రైబ్ చేసుకోండి. ఎవ్రీడే ఇలాగే మీకు కెమిస్ట్రీని మొత్తం సిలబస్ని ఎక్స్ప్లెయిన్ చేస్తాను. సో యూట్యూబ్లో సెర్చ్ పైన @ ఆర్జేపీ 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 25 సెర్చ్ చేసి నా ఛానల్ని సబ్స్క్రైబ్ చేయండి. ఓకే, థ్యాంక్ యూ వెరీ మచ్.